are 4 ways we have learned to solve systems equations. Well, we graphed first, then we learned substitution, and then we used combination and elimination, and then RREF, which is calculator. Alright? Now, number 2, all you're doing is taking these points and plugging, playing, and seeing if they work in these 2 equations. So the first one, if I plug 3 minus 5 times 2, which is 10, equals negative 5. Right off the bat, that's negative 7 does not equal negative 5, so the answer is no. I don't have to go any further. I don't have to do the other one. It doesn't matter if it's on the other one. It has to be on both or nothing. Negative 5, if I plug that in, I get negative 5 minus 0 times 5 is 0 equals negative 5. Check. The second one, 2 times negative 5 plus 10 equals 0. 10 times 0 is 0. Negative 10 plus 10 is 0. Check. So this is yes. That point is the solution to the equations. Okay. Next, any method you want here to graph these, okay? Cover-up method works really good because, well, this one is simply cover that up and y is 1, cover the y up and 0 is 1. So that's really easy. That's a really easy one. Alright? And you get, oopsie, you get a nice diagonal line that goes through, works a little bit off, like that. Alright? And then your next one, if you cover up, put a 0 here, and a marker. Alright. Cover that up, divide by negative 3, the y is negative 4. That's x. Y is negative 4. If we cover up the, put a 0 in here, we get x equals 6. Okay? And we get something that looks like that. So we draw our line. Okay? Move it on down. And it looks like it hits at right about, that's off. Hold on. That's the beauty of graphing. Okay, so the points move when the board moves, so now it looks like it's lined up in the right place. So it looks like it's at 3, negative 2. But remember, we don't just assume and move on, we check it real quickly. So when we plug into the first one, 3 plus negative 2 equals 1, check. And then 2 times 3 is 6. Negative 3 times negative 2 is 6, equals 12, check. So 3, negative 2 is the correct point. Alright. Okay, number 4 is nice because right off the bat you can tell that there's going to be no intersection because they have the same slope. But we still go through and graph it because we're supposed to graph it. So 4, up 2, right 1, up 2, right 1, and I'm just going to do a rough one here because we know they're parallel. Negative 3 is down here, up 2, right 1, up 2, right 1, and there you go. And so there is going to be no solution to this one because of the fact that they are parallel. They're never going to cross. And the solution is the intersection. Okay, this one, we're doing substitution. This one is already set up for substitution. All we need to do is plop this in right there. So we rewrite this as 3x minus 10. Don't forget the parentheses. 2 reasons. There's a negative and there's a coefficient. So you got to make sure you put that. Equals 24. You distribute your 10, or your negative 10 specifically, and you get 70x, and you get 170 equals 24. Right? You end up with 73x equals negative 146. When you divide by 73, you get x is negative 2. Now we're not finished. We got to plug this negative 2 back into either equation. Personally, I think it's easiest to plug it in right here, because that one's already solved for y. Negative 2 times negative 7 is positive 14. Minus 17 is negative 3. So I get negative 2, negative 3. So I've actually just plugged that into the first equation and proved that. I plug this in real quickly to this equation and find out that it is true. I can move on. All right, number 6 is a tricky one because it looks like it's very easy just to move this over, like so, but that's a negative x. You don't want negative x. So you have two choices. You can move the negative 2y over and then divide everything by negative 1, or you can move this over here and this over here. It makes no difference. You're going to get the same thing. Okay? If I move the x over, I'm going to get x equals negative 2y minus 3, which I'm going to plop in right here for x. Again, I use parentheses because I have a coefficient of 3. Negative 2y minus 3 plus 6y equals negative 9. You know you've done it right when you have nothing but the same variable left. All right? So that's going to give you negative 6y minus 9 plus 6y equals negative 9. The y's cancel. At this point, it's still okay. You end up with negative 9 equals negative 9. That's a true statement. If you get a true statement, that's all numbers. Anything will work. Everything will work. In other words, these two lines are the same line. Okay, they're the exact same line. All right, combination and elimination. Most people just call it elimination, but it's really combination because the goal is when you add them together, you end up eliminating one. So that's the full name of it. So number 7, again, there's many ways to do this problem. Okay? You can decide to cancel the x's or the y's. Doesn't matter. For x, 2 and negative 4, you need a 4 and a negative 4. For 3 and negative 5, you need a 15 and a negative 15. If I was going to cancel my y's, I would have to multiply this by 5 and this by 3, which is okay. It's just more work than if I just multiply this one by 2, which would give me a positive 4. So that's 4x plus 6y equals negative 14. Yes, that's important. And then I just drop this down underneath it. Negative 4x minus 5y equals 13. When I add them together, the x's go away. 6 minus 5 is 1y equals negative 1. At this point, I can plug this in here or here. It makes no difference. Okay? So if I plug in the first one, I get 2x. Negative 1 times 3 is minus 3 equals negative 7. Move the 3 over by addition, and I get negative 4. So x is negative 2. Remember, we're not done leaving it like this. You have to write it as a point. That's your answer right there, negative 2, negative 1. And you can go through and check that if you like. Plug it back in. Okay. Another way, like I said, for the final, if it's a multiple choice question, you can go ahead and make a matrix out of this real quickly. You just make it 2 by 3. Remember, the acronym is RC, remote control. There's 2 rows and 3 columns. You just put the numbers in. 2, 3, negative 7, negative 4, negative 5, 13. There's nothing wrong with doing this. And it's also a good check. It's a real quick check. Doesn't take very long. It's good practice on the calculator. It's good practice when you're studying for this test. You go through and do all these over again with the matrices, just to get the muscle memory going for your fingers. You run this, and what you'll get is, for an answer, you'll get 1, 0, 0, 1, and you'll get negative 2 here, you'll get negative 1 here, and that's what it'll look like. So on any of these, it's good practice to do the scrapping calculator. Okay, moving on to number 8. Now, on this one, you've got to make sure. A lot of people go, oh, if I just multiply this by -9 right now, I'll be okay. You can't multiply by anything until you get everything lined up. And right now, you don't have your x's, y's, and numbers lined up. This -12 needs to move over here. So this needs to be x plus 2y equals +12. Got to move it over. Now at this point, I can cancel my y's with a 10 and a -10, or my x's with 9 and -9. The simplest thing to do is this, because I already have a +9 right there. So I'm just going to rewrite 9x minus 5y equals -30. And I'm going to distribute my -9. -9x minus 18y equals -108. When I do that, I get -23y equals -138. And when I divide by y, I get a +6. At this point, I can plug this into either one. I'm going to plug it into the second one because x is already by itself. I save myself a step of divide by 9 at the end. So x plus 2 times 6 is 12 equals 12. X is 0. So my point of intersection is 0, 6. Now, number 9. It says use substitution or elimination. Remember, if this is multiple choice in the final, you could use matrices also. But it says use either one. Personal choice here. I personally like elimination more often than not because it seems pretty easy. But in this case, this is a pretty easy one to do substitution for. Now, a lot of people in class wanted to divide by -6 right here and get y by itself. The problem with that is you get a bunch of fractions over here. So it's not a really nice one. But along the same lines, you can divide everything by 2, which would then give you -3y equals 14 plus x. Then you just move your 14 over. X equals, well, let's see, I want to move my 14 over, I want to switch that. So x plus 3y equals 14, -14. All right? So I move the -3y over with the x, making it positive, and the 14 over become negative. Oh no, I'm sorry, I was doing it the right way. I'm not doing elimination, I'm doing substitution. I lost track of what I was thinking. So if I move the 14 over, I get x equals -3y minus 14. This I then plop right in there. 5 times -3y minus 14 plus 15y equals -24. 5 times -3 is -15y minus 14 plus 15y equals -24. The y's cancel, and I get this crazy statement of -14 equals -24. That is a false statement. If I get a false statement, that means there's no solution, which means these two lines, this one and this one, run parallel to each other. This point on, I made one of my errors of forgetting to distribute the 14. So you get 5 times 14, 5 times 4 is 20, here's a 2, that's -70. So what you end up with is -70 equals -24, which is still a false statement. Okay? Again, if you would have done substitution elimination, you would have gotten a false answer also. Doesn't matter what the false answer is, it's just if you get a false statement, it is no solution. If you get a true statement, it's all solutions. Okay. Okay, now number 10 looks like it might be a good one for substitution because of this y, but you've got some fractions going on, which would make substitution a little bit more challenging. So if you look at it, you have 2y here and a y here. If you multiply by -2, two things happen. You'll be able to cancel the y, and this is going to cancel with the 2, which works out very nicely. So So I multiply negative 2 times this. The 2's cancel. I end up with negative 6x minus 2y equals negative 6. And then down here, I got negative 3x plus 2y equals negative 2. My y's cancel. I end up with negative 9x equals negative 8. Nope, that's not negative 6x, that's negative 3x. All right? That makes that 6. I knew we did something wrong. That's what I got. Negative 6, divide here. X is 4/3. Now, just because it's a fraction does not mean you have to go back and redo substitution elimination for the other variable. Because, you notice here, you have negative 3. If you put this in for x there, the 3's will cancel. So let's do that. Negative 3 times 4/3 plus 2y equals negative 2. The 3's cancel, but be careful, you're not losing the negative. So you get negative 4 plus 2y equals negative 2. We move the 4 over and get 2y equals 2, y is 1. So my point of intersection is 4/3, comma 1. All right. Again, we can use anything we want here, substitution or elimination. But notice, not in the proper format. I need to switch those places. So 10x plus 3y, then change sides, equals positive 42. Now I could recopy this down, but I'm looking ahead and seeing the negative 9 here. I'm seeing a positive 3. I'm just going to multiply right now by 3 to save space and get 30x plus 9y equals 126. Now I move this down underneath it. Negative 4x minus 9y, which will cancel, equaling 30. I end up with 26x equals 156. When I divide by 26, I get x equals positive 6. Which I'm going to plop in either here or here. Doesn't matter. So I'm going to plop it in the second one, 10x. So 10 times 6 is 60. Minus 42 equals negative 3y. 60 minus 42 is 18. Negative 3y, which means y is negative 6. So my point of intersection is 6, negative 6. And once again, good practice. You could put this in a 2 by 3, and you have negative 4, negative 9, 30. And make sure you're looking at the right one here. 10, 3, and 42. So anytime you get a chance, practice these on the calculator. Number 12. This one looks a little scary because of the decimals to some people, but that's not a big deal. If you don't want to think about 1.5 and 4 having a common multiple, just think about 1/2 doubled is 3, and then compare 3 and 4. So basically, to cancel y's, you're going to want the magic number 12 and negative 12. Or if you think about 5 and 3, you're going to want 15 and negative 15. It really makes no difference. It's just what you multiply by. So I'm going to do 12 and negative 12. So 4 goes into 12 negative 3 times. Or I'm going to do negative 3 for that one. Now, 1.5 becomes 3. 3 goes into 12 4 times. But because of 1/2, this is going to be 8. Okay, so 8 times like $1.50 is going to be $12. So now that I'm going to multiply those out. So 8 times 2.5, that's going to be 20x minus 12. Oh, I don't have to worry about the minus here because I already have a minus up there. minus 12y equals negative 24. Now multiply by positive 3, 9x plus 12y equals 7 times 3 is 21, 9, 111. I get 29x, those cancel, equals so that's going to equal 87 divided by 29, and x is 3. To make life easier, I'm going to plug my x in here instead of dealing with the decimals. So 3 times 3 is 9, plus 4y equals 37. Subtract 9 from both sides, and I get 28 divided by 4, y is 7. So I get the point of intersection of 3, 7. Moving on. Solutions. Systems of equations with real world problems. Alright? So this is a classic one. We're going to have number, 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 value, value, value. Always start off by identifying your x and your y. Okay? So I'm just going to go in order. X is adult, and y is student. Now you just have your equations. You have some unknown number of adults plus some unknown number of students, and you know the total number is 86. You know the cost of an adult is 25, and you know the cost of a student is 13. You know the total cost or money spent was $13.70. At this point, you have a choice. This is very easy to solve for substitution. You can move the y over and have x equals 86 minus y. You can move the x over, y equals 86 minus x, and then plug those in. You can multiply by either negative 25 or negative 13, or you can set up a matrix. On any of these problems, 1, 1, 86, 25, 13, 13, 70. Any of those methods will work. I'm going to go and do elimination on this one. I always go with the smaller one. I do 13 instead of 25. That way I avoid negatives. So yes, if you're doing this on the quiz and it just says your preferred method, the matrix is a perfectly valid method to use. There's nothing wrong with it. It doesn't tell you you have to use substitution or elimination. It says your preferred method. And we have taught you this method so you can use it. I'm going to go though and do this. Negative 13x minus 13y equals negative 1118. When I add these together, hence the combination, I get 12x equals 252. When I divide by 12, x is, and y, yeah, x is 21. I plug 21 in right here, and I find out y is 65. So that means I'm not done yet. That means 21 adult and 65 students. That's my answer. If you don't go all the way to this point, you will not get full points. You've got to write out in words what the answer is. And again, if you were to run a matrix, it would look like this: 1, 0, 0, 1, 21, 65. Okay, now this is the other kind of problem we did. This is the kind of problem where we have two different situations and we're comparing them. You have a fee, okay? You have a fee just for usage, okay? Whether you want to call it room usage or rental fee or whatever. Then y is the per guest cost. You don't have to write it all out, it's per guest. Or you just write guest, whatever. Just as long as you know what's going on. These are great problems because they're really simple. Because you have the initial fee, and just think real world. Think common sense, and these problems kind of lay themselves out for you. You have to pay money to rent the room. Then you have a cost per person. The first event has 46 guests. 46, and there's the per guest fee. This event cost $771. The second event, you had to pay for the room. Then you had to pay per person, which was 150 people. And this one cost $21.75. So again, if you wanted to, you could put this in the matrix and do 1, 46, 771. 1, 150, 21.75. But these are stupid simple problems because all you have to do is cancel the x's with one of them being negative. Again, I always pick the smallest one, so I'm going to pick the first one because of the 46. And you can physically multiply by -1 like this, or you can just go negative, negative, negative. Whatever you want to do. When you add them together, the x's cancel. You get 104y equals 1404. And then you get this crazy answer of 13.5, and you'll freak out and go, wait a minute, how can I have 13.5 guests? Remember, the 13.5 is the charge per guest. That means $13.50. Now it says, how much is Shelley's fee and what's the charge per guest? So we do have to plug this y in here or here, makes no difference. And then solve for x, which is very simple. All you do is take 1350 times 46, subtract it from 771. And you end up with x equals 150. So, it's a $150 fee and $13.50 per guest. Travel agent offers 2 packages, nights and tickets. Those are the key words you're looking for. What words occur in both situations? And then you have your x and y. X is your nights, and y is your tickets. All right? So, all we do is look for the numbers. 3 and 2. Bam. 3 and 2. It's that simple. Cost is $645. Second package, 5 and 3. 5 and 3. $1,055. Now, for this one, elimination is your best option, as if you're not doing matrices. You can do x's with 15 and -15, or y's 6 and -6. You pick. I'm going to go with 6 and -6. At this point, one of them has to be negative, so you just pick. It's arbitrary. It doesn't matter. You'll get the same answer. So you get -9x minus 6y equals -1935. And then you get 10x plus 6y, which cancels, equals 2110. This one works out nicely because 10 minus 9, I get right to x equals 175. Now notice the question is just how much per night. I already got that right there. 175 per night. I'm finished. I don't have to find out the ticket price. But if it said both, all I would do is plug the 175 in for x and solve for y. Okay, last page. Solve using system of equations. So very simple. Okay, one thing to point out. I'm seeing a lot of people in class just writing, number, and writing down the answer and showing me this. That's not enough. That's not what I'm looking for. If you get it wrong, it's all wrong at that point. If you want partial credit, based on doing it mainly right, I need to see your setup, your augmented matrix in the instructive directions. So -5, 9, -7, 0. I need to see this. 9, 9, 9, 0. 7, -1, 3, -36. Now this one I'm going to run here. I'm going to run live. Okay,
So we're going to go into matrix right here. Go over to edit. And remember our acronym. We have 1, 2, 3 rows, but we have 1, 2, 3, 4 columns. So it's a 3, enter, 4, enter, 3 by 4. And then we just put our numbers in. -5, enter. You hit enter every time. 9, enter. -7, enter. 0, enter. 9, 9, 9, 0. 7, -1, 3, -36. Now remember, at this point, do not try to calculate your matrix. If you do, it's going to put it right here. I'll show you what it looks like because many of you have done it. Second matrix, you go over to math, you go up or down to RREF, and you tell it to choose A. The problem is, with this stuff in front of it, you're going to get an error. So you've got to make sure when you're in matrix, after you've entered it in, you got your nice little matrix there, you must do second quit to clear your screen. Then you come back into matrix, you go over to math, again up or down, it's a little bit faster going up, RREF, and then all you're doing is telling it which one to look in. This is just like when we did stats and we entered things into L1, then we told it to look at L1. It's the same concept. One is already highlighted, all we have to do is hit enter twice. And there's our answer. So we get -8, 1, 7. Remember though, you must write it as a point in space, X, Y, Z. If you want to write out the full thing like this, that's fine. I really don't want you to really waste your time doing this on the quiz. I'd rather you spend your time finishing the quiz, doing it well. So this part is not necessary at all. I'm just worried about these last 3 numbers. If you did it right, I know what this part's going to look like, so you don't have to write that out. But I do want to see the augmented matrix to start. Then your answer written as that. You can't just circle this and say it's your answer. You can't, put it like this outside of it. You need to see it written as a point in space. Moving on. Augmented matrix. -1, -4, -6, -9. -4, -4, -4, 0, 9, -7, -4, 75. You run it through the exact same thing. I cannot stress enough how important it is to practice the keystrokes over and over. Whether it's different problems or the same problem, get the keystrokes down so it's second nature to you. When you run this, you end up with 3, -12, and 9. That's it. Now, number 18, I'm going to run the long way through. Number 19, I'm going to show you this, how you can actually do it without all the work, but then I'll show the work for it. Remember, I said start off by writing it this way every time. Just to make sure you don't make a mistake in setting up your matrix at the end. Okay? Now, all I'm going to do is do this one first. I'm going to plug -1 in for x. So I'm going to put a, -1 squared, b, -1, c, and 9. That's my y. Alright? C is always just going to be C on these problems. You don't have to worry about it. It's always going to be C. That column is always going to be 1s. Now, all I do is calculate. -1 squared is +1. And all I'm going to do is write that in front of the A. I don't even have to write a 1. I just write A. And then, be careful here. -1b plus c equals 9. And as I suggested to you, you might want to do that. Just to make sure you know where you're looking. And then I'm going to look at this one. So, A, 1 squared, plus B, 1, plus C equals -1. Again, 1 squared is 1, A, plus 1B, plus, if you wanted to put the 1 there, C equals -1. There's my second line of my
matrix. Here, 3. A, 3 squared. That's supposed to be that, sorry. Plus B, 3. Plus C equals 13. Now I just square 3 and put it in front of the A. I move the 3 to the front of the B. The 1C equals 13. Now I'm ready for my augmented matrix. 1, negative 1, 1, 9. 1, 1, 1, negative 1, 9, 3, 1, 13. When I get my 3 answers, it's going to be 3, negative 5, 1, like that. Now in this case, it's not X, Y, Z. It's actually A, B, C. A, B, C. A, B, C. So all you have to do is look back to the original equation and plug these in right here. Y equals A, 3, and then put your X squared. Minus 5, that's my B, X. Plus C, which is not C, it's 1. And I'm finished. Now, for this one, I want to show you how you can actually go, if you see the pattern, go from here right to here. Then I'll do the work. You see what's going to happen here. Negative 1 just became, I squared it. I just wrote the negative 1 here. This is always 1. That's y. This is just 1 squared. This is just 1. This is always 1. And this is negative 1. 3 squared, just 3. Always 1, 13. So watch. Negative 2 squared is 4. Then I write the actual negative 2. Then there's the 1. Then there's the negative 19. 2 squared is 4. 2 by itself is 2. This is always 1. This is negative 3. 4 squared, 16. 4 by itself, always 1. Negative 19 again. If you see it, you can go right to the augmented matrix just like that. Otherwise, again, you go write this first, and then start plugging in. A, negative 2 squared, which is going to give you your 4A, plus B, parentheses 2, which is going to give you your 2B. That's just going to be, this is negative 2, right? Yeah, negative 2. So B, negative 2, negative 2B, plus C equals negative 19, plus C equals negative 19. And then there's my first line of my matrix, right there. Alright? Then the second one, we're plugging in 2, negative 3. So A, 2 squared, plus B, 2, plus C equals negative 3. 2 squared is 4, A. 2 by itself is 2B, plus 1C equals negative 3. There's my second line right there. And last but not least, A, 4 squared, plus B, 4, plus C equals negative 19 again. 4 squared is 16A. 4 moves in front of the B, plus 1C equals negative 19. Okay? My answer for that, I get my numbers spit out. They are negative 2, 4, and negative 3. That's the last column of my matrix. So to plug it back in, I go to my original equation. A, B, C. Negative 2x squared. 4x minus 3. I'm done.